going to cover solving systems of equations by graphing. Okay, a system of equation is just two equations where they both have an x and y in it. Okay, by graphing, the purpose is to figure out where they cross, and where they cross is where your solution will be. So, most of you like to graph these using slope-intercept form. So we get this into slope-intercept form, we add the 2x over, we subtract the 4. Alright, if we graph that, down 4 for our y-intercept, and then up 2 over 1 for our slope. And I like to put in a third point just so I can draw a straighter line. And there's my first point. Alright, if we do the same thing with the other one, we subtract the x over, negative x minus 1. Doing the same thing, I would go negative 1 for our y-intercept, and then down 1 and over 1 for our slope. And there is that line. Where do the two lines cross? The two lines cross at the point 1, negative 2. Now what you can always do with these is you can always throw these back into the equation to see if it works to check. So negative 2 minus 2 is negative 4 plus 4 is 0. And negative 2 plus 1 is negative 1, which also works here. It has to work for both of them to be a solution to this system of equations. If it does, then that's your answer. If it doesn't, go back and figure things out. You must have screwed up along the way then. Alright, we can have lots of different systems of equations. If you have one that has at least one solution, so like we had on the last page, that is a consistent system. Now you can have systems that have lots of answers or just one answer. They are still both consistent systems. If you get one where there's no answers, then that's an inconsistent system. Alright, so if the lines are parallel, then they're never going to cross, so then they would be inconsistent. Okay, if they are consistent, then you have to figure out, are they dependent or independent? Remember, consistent means that it has at least one solution. Dependent means, as it says here, one of the equations in the system contains all solutions common to the other equation in the system. That means that we have one line, and then we have another line, and they are right on top of each other. So if you have two lines where you have an infinite amount of solutions, this would be a dependent system. It would also be a consistent system. If not, as it says here, if they are not right on top of each other, so like the first one, where they just cross once, then it's an independent system, where one does not depend on the other for all of the answers. Alright, so how do we do this? Determine if these are consistent, inconsistent, dependent, or independent. Well, if we do this first one, the first thing that I see here is if we multiply this whole thing by 2, I get the exact same equation as the one on the bottom. Since these are the same, then wherever that line is, say that it's there, the other one is going to be right over the top of it. Okay, so because of that, we do have a solution here. So that means that this is a consistent solution.
Excuse the interruption. Could I have junior high football players please go to the high school gym for pictures? Junior high football team, please go to high school gym for pictures. Thank you.
Because it is consistent, it can also either be dependent or independent. One line depends on the other for all of its answers. That means it is dependent. So it's a consistent, dependent system of equations. For our second one, first thing I see is they're telling us, well, x equals 3. Well, then that tells me, well, I can put 3 in for x. Well, what does y have to equal if x equals 3? Y also has to be 3. So our answer here for this one is 3, 3. We've got an answer, so this is consistent. Okay, we only have one answer though, we don't have lots of them, so this is independent. Alright, back here on this last one, because both of these lines are on top of each other, what we say for that is we say there are an infinite amount of solutions. So infinite solutions. Alright, for our next one. First thing I see is first, they are set up in slope-intercept form. Alright, so what we can do is, if you wanted to, you could plug this one right into our second one for y, or you could look and say, well, our slopes are the same. So that means these lines are either on top of each other or parallel. Our y-intercepts are different then. So what that means is we have one line that looks like that and another line that looks about like that. Okay, if those lines are perfectly straight, those are parallel lines. So because they're parallel, there is no solution here. So this is an inconsistent system. Alright, next page. Alright, so a cell phone company charges 60 cents for each text message for customers not enrolled in a plan. We need to make an equation out of that. Well, the first thing that I see is, alright, it sounds like total cost, and we'll say that's y for now, equals 60 cents per text message. Well, what I want you to get in the habit of doing is saying, alright, what I'm saying there is x is the number of texts, and then y is the total cost. We need to do that so that we know what these variables stand for after we get rolling here with this problem. And when we solve for either x or y, then we know what it actually means. If we go to our next one, customers in the plan pay $10 each month and 10 cents for each text message. So, total cost equals $10 plus, they're paying $10 no matter how many texts they send every month, but then it's 0.1 times the number of texts. Alright, well, you could graph these out if you wanted to, or because these are both set equal to y, we can just roll that right in there for y. 0.6x equals 10 plus 0.1x. Solve for x, we're going to move that over, so 0.5, x equals 10, x equals 20, and as we set up here, our x is the number of texts. So, when are these equal to each other? Is when each send 20 texts. Well, why would we use this in real life? Well, if you don't send a whole lot of texts, for example, my parents don't text at all, wouldn't they want this first plan then? Because they can have this phone and it's not going to cost them anything. Or maybe they just text a very little amount of time. If they're like the normal teenager and they're texting a lot, well, anytime you get over 20 texts, that means that this other plan is going to be your best bet. Alright, so in real life, you're going to have to pay attention to this. You're going to have to find what's called the break-even point, and that's what we solved here when we solved for x equals 20 there. Alright, anything below, the one plan is better. Anything above, the other plan is better. Alright, any questions, please let me know.